It works on my machine. 4 small words that have started more arguments between developers than almost anything else in software. You build something, it runs perfectly on your own laptop, every test passes, the whole screen is green. Then you hand that exact same code to a teammate or you push it up to the server and it immediately falls over. A different version of some tool, a library that is missing, a setting that quietly only ever existed on your computer. The code itself did not change at all, but the world around it did, and suddenly nothing works. For decades, this was just a painful, accepted fact of life. And then Docker came along and quietly made that entire class of problem more or less disappear. Once you really understand how it pulls that off, a huge slice of how modern software actually gets shipped finally clicks into place. Here is what really goes wrong underneath all of that pain. Your application never truly runs alone. It leans on a specific version of a language, a whole pile of libraries, a handful of system tools, some environment settings, maybe even a particular flavor of Linux. All of that stuff together is the environment your code needs to breathe. On your machine, you slowly assembled that environment over months, usually without even noticing you were doing it. But the server has its own environment. Your teammate has a different one. The test system has a third one. Every single one of them is subtly, invisibly different, and your app is quietly depending on tiny details that only ever existed in your particular setup. So it runs beautifully for you, and it breaks for everyone else. People used to write long pages of setup instructions to paper over this, and those instructions went stale the very moment anybody changed anything at all. So Docker does one clever thing that completely changes the game. Instead of shipping just your code and then praying that the target machine happens to match, you package your code together with everything it needs to run, all sealed inside one bundle. The exact language version, every single library, the system tools, the settings, all of it wrapped up neatly into one portable unit called an image. That image then runs identically anywhere Docker is installed, whether that is your laptop, a colleague's machine, a test server, or a giant cloud data center on the far side of the planet. The environment stops being this fragile thing you cross your fingers is correct on the other side. It now travels with the app baked right in. Works on my machine quietly becomes works on every machine because it is, quite literally, the very same machine packaged up and carried along for the ride. Let me properly introduce Docker itself by name. Docker is an open platform for building, shipping, and running applications inside containers. It first arrived back in 2013, and it genuinely reshaped how the entire industry deploys software. But please do not let that big reputation intimidate you because the core idea underneath is refreshingly simple. Docker lets you take an application, along with its whole environment, and pack it neatly into a container that then runs the exact same way absolutely everywhere. It hands you a simple recipe format to describe that environment, a clean way to build it into an image, a place to store and share those images with other people, and a lightweight engine to actually run them. That is genuinely the whole toolkit. A few small moving parts that, working together, finally make software portable in a way it honestly never truly was before. Think of a container as a sealed, running box wrapped tightly around your application. Inside that box, your app sees its very own private little world. Its own files, its own libraries, its own dedicated slice of the system, arranged exactly the way you originally packaged them. It cannot see the mess sitting on the host machine outside, and the host, in turn, cannot accidentally reach in and break whatever is inside. You can run 5 completely different containers side by side on one single computer, each one carrying a different language version, each one packed with conflicting libraries, and they will all happily coexist without ever once stepping on each other. That clean isolation is the real magic of the whole thing. Each container is a tidy, predictable, fully self-contained environment. Ship that container and you ship that entire clean little world right along with it, so that whatever runs on your desk is byte for byte identical to what runs in production. Now for the comparison that everyone immediately asks about. Haven't we been able to do roughly this for years already, using virtual machines? Well, sort of, but there is one absolutely crucial difference. A virtual machine emulates an entire computer from scratch. It runs a full guest operating system of its very own, stacked right on top of your real one. That means every single virtual machine has to haul along gigabytes of operating system, and it takes minutes to boot up, just to run your one small app. A container is dramatically thinner than that. It does not carry its own operating system at all. Instead, every container running on a machine quietly shares the single kernel of the host sitting underneath them all. It packages up only your app and the pieces directly wrapped around it. So where a virtual machine is a whole separate house built on your land, a container is just one locked room inside the house you already own. The same isolation, at a tiny fraction of the weight, There are two words people constantly mix up here, so let us nail both of them down cleanly. An image and a container are not the same thing at all. An image is the blueprint. It is the frozen, read-only package that holds your app and its whole environment, just sitting there on disk, doing nothing, patiently waiting to be used. A container is a living, running instance of that image, actually brought to life. The relationship is exactly like a class and an object in programming, or like a written recipe and the finished, steaming meal on the plate. From one single image, you can start one container or 100 perfectly identical ones, all at the very same time. The image is the template that you build once and share. The container is the thing that actually runs. Keep those two ideas straight in your head, and honestly, the rest of Docker suddenly stops feeling confusing. Here is where the blueprint actually comes from in the first place. You describe your image in a plain text file called a Dockerfile. It is really just a short, ordered list of steps, read from the top straight down to the bottom, that spells out exactly how to build up your environment. Start from a base, say a small Linux with a particular language already installed on it. Copy your code in, install all your dependencies, state the one command that should run the moment the container starts up. And that is basically the entire thing. Because that recipe lives in a file sitting right next to your code, your environment is now version controlled and reviewable, exactly like everything else in your project. Anyone on the whole team can open it up and know, precisely and completely, what is inside. No more secret setup knowledge living quietly in one single person's memory. The entire environment is written down, out in the open, as plain code. Watch how that image gets built from the Dockerfile, because this particular part is genuinely elegant. Docker does not build your image as one big solid lump. Instead, it builds it up in layers, one distinct layer for each step in your Dockerfile, neatly stacked on top of each other. Start from the base, that is one layer. Copy your code in, that is another layer. Install your dependencies, that is yet another layer on top. Each layer only ever records what actually changed from the one directly below it. And here is the genuinely clever payoff. Docker carefully caches every one of those layers. So when you change only your own code and rebuild, Docker simply reuses all the untouched layers underneath, and only bothers to redo the ones that truly changed. Rebuilds that could have taken minutes now finish in mere seconds. Layers are even shared between different images, so 10 apps built on the same base do not store 10 separate copies of it. They all quietly share the one. It is efficient the whole way down. Now follow the whole journey from end to end, because it really is only 3 simple moves. Build, ship, run. First you build. You run a single command, Docker reads through your Dockerfile step by step, and out the other side comes one finished image. Next you ship it. You push that image up to a registry, which is really just a shared library for storing and handing out images. The best known one out there is Docker Hub, but every major cloud provider runs its own as well. Anyone with the right access can now pull that exact same image right back down to themselves. Finally, you run. On any machine at all that has Docker installed, you pull the image and start it, and your app springs instantly to life inside the identical environment you originally built, whether that happens to be your laptop or 1,000 servers in a data center. Build it once, push it once, and then run that very same frozen image absolutely anywhere. No painfully reassembling the environment on the far side, ever again. Now for the number that makes this whole difference really land. Think for a second about simply starting your app up. A full virtual machine has to boot an entire operating system first, and that can genuinely take minutes every single time you do it. A container skips over all of that completely because the operating system it needs is already running underneath. So a container can start in well under a second. And on top of that speed, the images themselves are tiny by comparison. A virtual machine has to drag along several gigabytes of operating system for every single copy. A lean container image, by contrast, can be just a few megabytes because it only ever carries your actual app and the thin little slice wrapped around it. Under a second to start, a few megabytes to ship. That gap right there is exactly why you can comfortably run dozens of containers on one machine and spin brand new ones up the very instant traffic arrives. So where does this actually pay off out in real working life? 3 places over and over again. First, local development. Your whole team runs the exact same container, so the app behaves identically on every single laptop, and brand new hires are up and running in minutes, instead of losing days to fiddly setup. Second, continuous delivery. Your automated pipeline builds one image, runs all your tests against that image, and then ships that very same tested image straight into production. What you actually tested is precisely what actually runs. Nothing quietly gets rebuilt or subtly changed somewhere along the way. Third, microservices. Large systems get split up into many small services, and each one lives inside its own lightweight container, started, stopped, and scaled completely independently of the others. From one single developer's laptop all the way up to the biggest platforms on the entire internet, it is the same portable image, doing the same reliable job everywhere it lands. You can see all of this yourself right now, completely out in the open. Docker Hub is the enormous public registry where ready-made images actually live, and it holds many millions of them. Official images for almost every database, language, and tool you could possibly name are just sitting there, one short command away from running on your machine. Head over to Docker Hub or to the main Docker website, and you will find polished getting started guides, a searchable browser, and copy and paste commands that spin real, working containers up in a matter of seconds. You genuinely do not have to take a single word of this on faith. You can pull a real, production-grade image this very afternoon, run it on your own laptop with just one line, and watch the whole thing simply work. The barrier to actually trying Docker for yourself is basically nothing. And that one fact alone is a big part of exactly why it ended up absolutely everywhere. A few honest warnings now, because Docker is a tool, and it is not actual magic. First, keep your images small and lean. Start from a slim base and do not copy in a pile of junk you do not actually need, or your images balloon up, bloated and slow to ship around. Second, never bake secrets directly into an image. Passwords and keys written into a layer are frozen right there forever, and anyone who pulls that image down can dig them straight back out again. Pass your secrets in at runtime instead, from the outside. And third, aim for just one main process per container. The whole model quietly assumes that each container does a single, focused job. Do not cram a database, a web server, and a background worker all into one box. Give each of them its own dedicated container. Respect those three simple rules, and Docker stays exactly the clean, predictable tool it was always meant to be. Let us bring this whole thing together now, into 3 clean lines. 1. A container packages your app together with its entire environment, so that it runs identically absolutely everywhere, and works on my machine finally becomes works on every machine. 2. Containers are far, far lighter than virtual machines because they all share the host's one kernel instead of each booting a whole separate operating system. And that is precisely what makes them so small and so fast. And 3. You describe an image just once in a Dockerfile, you build it, you push it up to a registry, and then you run that exact same image anywhere at all from your laptop straight to the cloud. Package once, run anywhere. That, honestly, is the entire story of Docker in a single nutshell. If Docker has finally clicked into place for you just now, then please do the one small thing that genuinely keeps this channel alive and growing, and subscribe. We are steadily building out a whole series that quietly demystifies all the tools that every single developer is somehow just expected to already know cold. Docker, remember, is how you package one app so that it runs anywhere. But what on earth happens once you have hundreds of these containers spread out across dozens of different machines, and you need every last one of them started, healed, and scaled automatically, all on its own? That is a completely different and genuinely fascinating problem, and it has a name: Kubernetes. It is the perfectly natural next chapter after this exact one, so go ahead and hit subscribe, and I will see you right there in the very next video.